the polymers are made? Mainly by two types of mechanism, addition and condensation. By addition mechanism, we are getting mainly plastic type of polymer, thermoplastics. By addition mechanism, we are getting thermoplastics. And by condensation, we are getting that condensation polymers like nylon. And by cross-linking polymers also we obtain. Chain growth and step growth. And there is a third one called real world. Chain growth, plastic type. Step growth, that hard type of polymer which is cross-linked most of the time. And there is a third one called real world example. Because most of the time we blend the polymers and use them, not the pure one. That is real world. Like we know there is a rubber material, there is a plastic material, but if we blend the two, rubber and plastic, we get thermoplastic elastomer. For example, Hawaii chappal, that is a thermoplastic elastomer. Anybody talking here, please get out. This is not a gossiping class. Okay, let's start. So this chain growth polymer, they are plastic materials, and the step growth polymers, they are cross-linked polymer most of the time, like backlight, nylon 6, they are called step growth polymer. Why they are calling step growth? Why do we call them step growth? Because this growth of the polymer is controlled by stepwise addition. One by one molecules are getting added up, and molecules are slow. Just mind it. They are not very fast. They are slow. So movement is very slow, restricted. One by one molecules are getting added, which is very slow process. That is the difference. And is also falling in equilibrium, means reversible process. Organic reactions, reversible, molecules are adding very slowly. And chain growth, they are these molecules, they are getting added very fast manner, random fashion. There is no control. Just think. In one case, there is no control. That whenever you add monomer, immediate polymerization will take place and very fast reaction. We have no control. But step growth, we have a lot of control. Because it is slow, it is reversible. We can check the reaction according to our necessity. And practically, what is real world example? We are not using any pure polymer. We are blending polymers for our several purpose. Okay. So real world example, just like I told you, Hawaii chappal, it is a combination of two things. One is the plastic, other one is the elastic. Elastic is rubber. So plastic and elastic combined, that is called thermoplastic elastomer. Thermoplastics are moldable, and elastics are usually not moldable. Once rubber is used, afterwards can you use the rubber once again? No, because it is cross-linked. Rubber is usually cross-linked, so cross-linked rubber we cannot reuse or recycle. Reuse possible, but recycle not possible. So rubber, this cannot be recycled, but this plastic material can be recycled. So if I combine the two, so practically in the real world example, we are combining different type of polymer and we are making our materials. Now here the next point given here is types of polymer: natural, cellulose, natural, rubber, protein. So these type of different polymers are there. They are all natural polymers. Cellulose, natural polymer, you know, cellulose. So people are using cellulose. I was recently watching one video. Sometimes some useful video is there, particularly in the Facebook also. Most of them are fake, I know, but some of the video are true. So one of them, just I want to mention, you know, banana plant. From the banana plant, practically what we do, banana plant we dispose. After taking the banana, we cut the banana. Sometimes people are eating the middle stem, thod jetake bole. Okay, that middle stem portion also some people are eating. But what about the whole other things? The lot of peels are there and leaves are there, but some portion of the leaf may be useful. Other things normally we dispose, right? 80% of this plant we are disposing. Instead of that, processing can be done, and out of that, just like jute, threads can be made, yarning can be done, and you can make some cloth or bag like material. Bag we can make out of that. If not very good garments, may not be very good garments, but bags can be made. Okay, packets, different type of packets, bag, packaging material for food storage, it can be used. That's a new idea, isn't it? People are normally what people are doing here at India, what we are doing, disposing, but some people are using, like Vietnam. Okay, just I was observing that this is actually people are doing. So that's why the cultivation of this banana plant there is enormous. You can sell the banana in the market, and the plant is also not disposed. From there, they are making the threads, the yarning, and out of that the different type of bags can be packaging, that packets for the packaging, bags. These things can be made just like jute. This can be used just like jute, and it is easier. Jute is difficult. Jute means separately cultivate. You have to cultivate. After that, you have to take out the threads. Lot of processing there. But here, nothing. Squeeze. Made the water out. Okay, and after that, you can make the threads. That's the application of natural polymer. That's why I mentioned here. This is an application of natural polymer, isn't it? Cellulose. What is the use? Cotton. Cotton is cellulose. We are using our garments out of cellulose. Isn't it? Cotton is cellulose. So our garments made of cellulose. Natural polymer we are using. But if we use pure cotton, maximum time there is problem. There will be crease. So to make it crease free, we are mixing some polyester thread with that. So that's why it is called 80-20, 40-60. That type of blending is there. So most of the time, what are the materials we are using? Polymeric materials. It is in the real world. We are not using the pure polymer. We are blending things. Sometimes natural and artificial both blended together. Modification of the surface. Okay, like cellulose is a natural polymer. We are modifying the surface with acetylation. It is called cellulose acetate, cellulose diacetate, cellulose triacetate. What is the purpose? Have you heard about cellulose acetate, diacetate, triacetate? Out of these polymers, we are using some membrane for separation. Membrane separation. Have you heard about the name? Membrane separation? Ultrafiltration, nanofiltration, microfiltration. Have you heard or not? What is microfiltration? What is the purpose? Why do you use microfilter? Any idea? To remove bacteria. Okay, microfilter is used to remove bacteria. And glass, powdery glass in the injection. If you want to remove all this, microfilter is good. Small attachment available for microfilter. Okay, I am a specialist in that field. The membrane separation technology. It is a membrane separation technology. What is microfilter? You can remove very small bacteria virus as well as glass powder into the injection. When you break the injection, that ampule, it is called ampule. Injection ampule. In that some injection material, medicine is there, and it is made of glass. The whole thing is made of glass. So if you break the thing, if you want to take the injection out, you have to break. So when you break, very fine glass powder is automatically get mixed up. That you cannot avoid. Just break, no? So automatically the glass powder getting mixed into the injection. And now you are injecting that to some patient which is fighting for his life. So if you inject that, the very fine glass powder can be very dangerous for that person. So what can you do? You can attach something that is called microfilter, that attachment that you can put into the injection, that syringe, needle system, and you can take out the injection without any glass particle inside. It can be totally filtered out. Okay. So you may think, I don't know whether you are thinking or not, that needle, how glass can enter the needle? Yes, it enters the needle also because it is very fine powder. It is so fine powder, it is entering through the very fine needle also. And if it can enter through the needle, it can enter through your the venules, okay, arteries, capillaries inside the body. It can pass through and it will cut the portion. So hemorrhage is inevitable, isn't it? Hemorrhage will be there. So how do you avoid that? Microfilter attachment at the mouth of the syringe. Isn't it a good idea? Okay, so this is one application of membrane. And how do you make the membrane? It should be not purely natural, always possible, but you can some modified polymer like cellulose acetate, cellulose diacetate, cellulose triacetate. This type of membranes are used. Synthetic membrane, but a small disc, and in that disc there is a support material both sides, and because the membrane is very thin and very much delicate, so membrane is inside and both sides there is support material, porous support material of plastic, and you can get that attachment. It's a small disc type. It is can be attached at the mouth of the injection syringe. On application, I told you. Have you heard about ultrafiltration? You know Tetra Pak milk, milk packet, Tetra Pak, Amul Tetra Pak. Have you seen or not? 4 layers. That paper box. In that milk is there. That is called Amul Tetra Pak. So what is there? Because 4 layers are there. Packaging 4 layers are there. That's why it's called Tetra Pak. Now that milk is condensed actually. It's not pure milk, it is condensed, more concentrated than the normal milk. Normal milk, how much water is there and how much protein there? Any idea? 7% is solid material and 93% water. In this milk, 93% is water, only 7% is solid material. Now, this Tetra Pak, it is 11% solid material. That means more concentrated. So this concentration, how do you do? By ultrafiltration technique. There is a polymer, there is a polymeric membrane, ultrafiltration membrane. It can separate out water and protein. So by that, we are separating 11% is becoming solid materials and rest is water. Acha, how much of us water? আমাদের কত পার্সেন্ট ওয়াটার? 70%. And another very miraculous thing, in the world also 70% water, and we also have 70% water. So that proves we are part of the environment. Isn't it true? We are 70% water, 30% solid, and our earth also 70% water and 30% solid. Isn't it miraculous? Isn't it? Okay, so this cellulose, natural rubber, protein, these things are all natural polymers. Sometimes we are using directly, sometimes by modification we are utilizing it. Then synthetic polymers, polyethylene. I think it is very much versatile polymer. Maximum time we are using this polyethylene. What is the use? Today I am discussing use. So what is the use of polyethylene? Tell me something. Bag, acha, best bag. Or anything more? Mug, jug, bucket, tumbler, what not? Small things that we are using every day, these are all polyethylene. Acha, polypropylene, can you give some example where you are using? Polypropylene, polypropylene, same thing. Polypropylene or polypropylene, where you are using? The table chairs we are using into the canteen, plastic table chairs, these are polypropylene. Okay, have you seen SBR, styrene butadiene rubber? Rubber eraser, right? I told you already. Acha, and what about polystyrene? It is also a hard material. So these type of materials are usually made of polystyrene and bakelite, sometimes combination. Okay. And every small thing, you have a small parts and attachment. Some portion may be bakelite, some portion may be polystyrene. Okay, always a combination of polymers, and that is called what? If you take different polymers to make a material, what you will call that? Composite material. Okay, hey, don't talk, listen. Composite material, what is that? You have multiple things, maybe multiple polymers. Maybe one polymer, one wood, a piece of polymer, a piece of wood combined. So these type of materials are called composite. Okay. So most of the time, if you analyze the thing, you will find it is a composite. A small pen into your hand, what is this made of? Plastic? You generally call plastic. Plastic is a very versatile term. We just call it plastic. Is it always the same plastic? No, different type of so many plastic. Shampoo bottle, container and your pen are the same. Container plastic is different. Sometimes they are recyclable, sometimes they are not. Achha, that pen, just come back to the pen. At the very tip, you have a very small rod-like thing. At the tip of this rod, you have a small ball. That's why it is called ball pen, isn't it? There is a very fine ball. It is made of steel. So a particular pen, see, a small pen, only 3 rupees or 2 rupees price. It also has so many things into it. Okay, ink is made of some chemical. It is inside the tube. Fine tube is there that we call refill. At the end you have a small rod like material that is made of steel. At the end there is a tip. At the tip there is a ball. So many things there into one pen. That is called composite. So most of the things we are using are composite. Pure things are very rare. Mostly are all composites. These and that are mixed together. A shoe we are using, shoe. What do you have? At the top, bottommost what do you have? Very tough rubber. Ammonite type rubber, hard rubber, because otherwise it cannot last long. Durability. Then you have in the middle layer, that is usually resilient. A bit delicate one, but it should have bouncing action. Up and down bouncing. Otherwise it will not be comfortable. So middle layer should be bouncing. That is a resilient polymeric material. Resilient. It is called resilient. Okay. The property is called resilience. And the bottom one is tough. Shoe sole. That is tough. Then middle one, resilient. And then the part that is at the contact of our feet, the material should be biocompatible. Like polyurethane. At least know the name of the polymer that you are using in our daily life. Okay. So that is always, don't think that everything made of rubber. No. So many things are there into one. A particular shoe I just analyzed to you. 3 different layers are there. Bottom layer, middle layer, top layer. Bottom layer is very hard material, which is usually cross-linked rubber. Middle layer, resilient material, is made of synthetic polymer most of the time, not rubber. And into our body contact, what you have is called polyurethane. This type of, if you have a good shoe, a bit costly one. Okay. Otherwise, don't expect so many things. So, chain growth, step growth, and controlling the process. So, chain growth cannot be controlled so easily because it is a very fast reaction and fast things are difficult to control. And step growth, as it is happening slowly, so easier to control. But still, we can have a control, different type of control there. You have 2 monomer units. Just first of all, heat the monomer before the reaction started. Heat it up to certain temperature. That is called preheating. Then mix the monomer unit. Preheating, and then you add it into the reaction chamber and you add some catalyst. I am talking about addition polymerization. Take the monomer, a bit elevated temperature like 40, okay, before beta reaction. Then add into the reactor and some initiator. What is an initiator? Radical generator. Hey, hasle mukhta ekdom bondo koro. Why you are smiling? Listen to me. So, what is talking about? That we are adding some initiator. What is an initiator? Radical generator. For example, ROR. That is called peroxo linkage. ROOR. Peroxo linkage. It breaks so easily. Why? Can you tell me why? Why it breaks so easily? Weak bond. Achha, why the bond is weak? Going into detail. Why the bond is weak? Lone pair repulsion and lone pair bond pair repulsion both exist. Oxygen has got lone pair, na? And also bond pair. So lone pair repulsion as well as lone pair bond pair repulsion. So many repulsion factors making the bond very weak. As the bond is very weak, whenever you expose it with sunlight, diffuse sunlight or little bit of heat, a little bit of elevated temperature, it will easily produce radical RO dot. RO dot radical. That is called initiation, formation of the radical. And after that, it will join with this monomer unit, forming another radical. That radical will join with another chain. That means reaction is started already. It is undergoing propagation. After initiation, it is undergoing propagation. Now, in the propagation step, the chain length is enhanced, getting enhanced. It is becoming longer and longer and longer. Long chain you are getting. Okay? Long chain. So, when the long chain is formed, you have got the polymer. So, polymer is made. Now, the reaction must end somewhere. Someone was yesterday asking me when it gets ended up. Obviously, whenever your reactant is getting over, it is ended. So reaction must be, sometimes the reactants are getting over, getting finished up, used up. Then the reaction will be stopped. No further supply of fuel. So automatically ignition will be stopped. Nah? So it's the same thing here. So your reaction is going on, propagating, and ultimately getting terminated. How termination can happen in different ways. Number one radical, another radical coming in front and face to face heat, forming the longer chain. This is one chain, this is another chain. So this is radical, join. So that clubbing possible. This is one option. Another option, this one is getting reduced and this one is getting oxidized. So this is radical. One part getting reduced, other part getting oxidized. That means it is supplying, one is supplying hydrogen to the other one. Sort of exchange. Okay. Both are getting stabilized. One is becoming alkene, other one is becoming alkane. This reaction is called disproportionation. And this is a part of termination. So during termination, this thing happens. Follow me? What are the key properties of polymer? If you want to use, you need to know the properties. What properties are very interesting, important properties? They are called the key properties of polymers. One is thermal resistance. See, you will become computer engineer someday. Okay, so computer engineer, what material people are using? Motherboard is very important part of this computer, right? So motherboard is very important. So what material you will be using for the motherboard? Because lot of the data transfer will be there, heating up the material. Material will be heated up. So how do you, what type of material will be using so that it can accept that sort of heat and will not be bent, not become bent. Otherwise it will become bent. It will become twisted, torn apart. So what type of polymer you will be using? So that knowledge, that is thermal resistance property, should have. The polymer, whatever polymer you are using, should be highly thermal resistant. Chemical resistance. If there is some chemical exposure, spillage, it should not get damaged immediately, or different type of material actually. So chemical resistance is also a property. One example I am telling you. Some containers we are using into our laboratory. For storage of chemicals, we are using some containers. Have you seen the containers? What type of containers we are using in the laboratory for storage? Hey, you two get out of the class. You two. Behind the girls. These two. इधर उधर क्या देख रहे हो? तुम लोगों को बोल रहा हूँ. निकल जाओ. Constantly बात कर रहे हो तुम. Hey, क्या रोल नंबर है तुम लोगों को? What is your roll number? Sir, 110. 110. And you? Huh? 92. Both will be reported and your fathers will be called. I'll call your father. Please stop in the class. So thermal resistance is a property. Chemical resistance is another property. Flexibility and toughness. Flexibility and toughness, that is obviously very resistant, tough material. That is how much tough it is. So chemical resistance, as I was telling, in the laboratory, you have seen we are storing some chemicals into some container. This container is made of what material? What do you think? Usually, you have seen we are storing some chemicals, na? You have seen those containers, 10-liter container, have you seen? ACL we are keeping, EDTA we have kept, that container, white color, বড় বড় কন্টেনারগুলো 10 লিটার কি মেটেরিয়াল, প্র্যাকটিক্যাল আইডিয়া থাকতে হবে তো, শুধু থিওরিকে মুখস্থ করলে তো হবে না। হোয়াট ইজ দ্যাট কন্টেনার মেড অফ? আবার প্লাস্টিক, ভেরি ব্যাড ওয়ার্ড প্লাস্টিক, না পলিমার প্লাস্টিক মানে কোন পলিমার সেটাই জানতে চাইছি। সবই তো পলিমার, সবই তো প্লাস্টিক, ওরকম বললে হবে না, স্পেসিফিক, বি স্পেসিফিক। হ্যাঁ, পেট, দেখ পেট তো খাবার জিনিস রাখে, কেমিক্যাল রাখে। দিস আর মোস্টলি পলিথিন প্লাস হাই ডেন্সিটি পলিথিলিন, এলডিপি, এইচডিপি, হাই ডেন্সিটি পলিথিন, হাই ডেন্সিটি পলিথিলিন, এইচডিপি, কোনো আইডিয়াই নেই তোমার, কিছু জাকুসি বলে দিচ্ছে। ওকে, এইচডিপি ওগুলো। আচ্ছা, খাবার জলের বোতল, ড্রিঙ্কিং ওয়াটার বটল, হোয়াট পলিমার ইট ইজ? পি, পেট, ইয়েস, মানে কি পিইটি মানে কি? পলিথিলিন টেরিথ্যালেট। টেরিথ্যালেট মানে স্ট্রাকচারটা জানো? টেরিথ্যালেট মানে জানো স্ট্রাকচারটা? টেরিথ্যালিক অ্যাসিড জানো? টেরিথ্যালিক অ্যাসিড জানো না? বেঞ্জিন রিং জানো? তাতে একটা CO2 লাগালে কি হয়? বেঞ্জিক অ্যাসিড। আর তার প্যারা পজিশন আর একটা CO2 লাগিয়ে দিই, তাকে বলে থ্যালিক অ্যাসিড। শুধু থ্যালিক অ্যাসিড না, ওটা হচ্ছে প্যারা পজিশন হয়ে যাচ্ছে। সো এটাকে বলে টেরিথ্যালিক অ্যাসিড। ওটা থ্যালিক, শুধু থ্যালিক হলো না, টেরিথ্যালিক। প্যারা পজিশন হয় টেরিথ্যালিক, আর যদি ওটা অর্থে হয় তাহলে থ্যালিক। বুঝতে পারছো? শুধু থ্যালিক হচ্ছে অর্থে, আর প্যারা হলে টেরিথ্যালিক, এটা বলে টেরিথ্যালিক অ্যাসিড। বুঝতে পারলে? স্ট্রাকচার বেঞ্জিনিং, CO2H in the para position, that is called terithalate. Now polyethylene, PET, polyethylene terithalate, ethylene glycol, now CH2H, monomer, একটা monomer, another monomer is terephthalic acid, combine them, make a polymer, polyethylene terithalate. So now you can imagine the structure, get it? So that is paid. You have to have some idea, na? Overall, what polymer you are using. So this polyethylene terephthalate polymer, it is mostly for food content. Our storage of food, like sometimes we keep biscuit, chanachur, that dry food materials we keep into some white container, na, plastic container. These containers are mostly, yes, PET. And drinking water bottle also PET. When we have different coloring material is added up, so different color we are getting, but the material itself is PET. So these are the properties required, but all properties will not, good property you don't get into one polymer. Some polymer utilized for this purpose, so there we need thermal resistance, sometimes we need chemical resistance, sometimes we need toughness, sometimes we need flexibility, sometimes we need electrical insulation, depending on our requirement. Achha, by the way, out of these so many properties I have mentioned, bakelite will have one property. Which one? Choose karo. Electrical insulation. Bakelite is used into switchboards and switches. That is because electrical insulation property is there. Very good electrical insulation property. And another one, that different polymer, actually all polymers are non-conductor, so we are taking some polymer for wiring also, the cover of the wiring, the coating, the wiring coating, that is made of polymer. These are all found to be electrical insulators. Some polymers are very very tough. Example, একটা tough polymer example বলো, ultra high density polyethylene, UDP, একটা হচ্ছে এবোনাইট। এবোনাইটটা কি? হাইলি ক্রস লিঙ্ক রাবার, more than 90% cross linking done. Okay, more than 90% cross linking done. The rubber is very very tough. It is called ebonite, EBONITE. Everyday application of polymers. Polymers we are using for different applications. Solar cell, fuel cell, photocatalysis. These are the properties there we are using. Why we are using? Application, we are talking about application. So these are the applications. Polymers are used into fuel cell, solar cell, photocatalysis, everywhere using polymers. Acha, some example I'll tell you that, like in case of battery, lead acid storage cell battery, inverter battery. So there we are using some separator, polymeric separator in between the cathode and anode. Cathode anode is made of metal, lead and lead oxide. Okay, anode is lead oxide and cathode is lead. So in between there some plastic separator is there. That polymer is usually polythene. Polythene is most common. Mostly people are using polythene because it is cheap, it is durable, it is chemical resistant. We are keeping chemicals also in that, so it is chemical resistant. It is versatile, very much versatile, recyclable, lot of benefit. That's why polythene is most common. May not be used everywhere, but it is the most common one. Okay, some applications more: packaging, textile, adhesive, coating. These are all polymers. Now, advanced industrial use: automotive, airspace, medical device, electronics. Some of the I'm mentioning some of the names, but it is not possible to mention all names. Everywhere polymer is used, isn't it so? Everywhere polymer is used. So versatile, so convenient. Still, polymer has got one great disadvantage. It is having a very long life. And long life for a chemical is not good. Is not good for us. So after use, if you just dispose the polymer, the disposal creates nuisance. The polymer is not getting mixed with the soil because it is not natural. Most of the polymers are synthetic, and these synthetic polymers are not getting mixed with the soil. So disposal is a problem. So what do you call it? What do you call it here? Solid waste management. Okay, generally we call this phenomena solid waste management. This, how do you do the solid waste management? Number one, we can go for recycling. Right? Obviously we can go for recycling. What else we can do? Bolo? Tomade ki mone asche bolo. One is recycling, I told you. What else? Reuse. Recycling and reuse, what is the difference? Recycling means melting, molding, making something new. That is recycling. Broken materials, jug bhenge geche, mug bhenge geche, ogulo ki goliye abar notun kichu. So you make it something new. That is remolding, right? So that is recycling. Reuse. Reuse ta ki rokom hobe? এ মা সে বাতিল করলে কেন, তাহলে ইউজ যদি করবে তো ঠিক কিনা? বাতিল যদি করতেই হয় ইউজ কেন করবে, আর ইউজ যদি অন্য কাজ ইউজ করবে। এক্স্যাক্টলি, এইবার ঠিক বলেছে। ইট ইজ ইউজ ফর সাম আদার পারপাস। Sometimes we do that for our convenience. Something we are disposed already. After that, suddenly came to our mind, okay, we can use it somewhere else, here. So we use it there, somewhere else. But still we are using. One example, that water bottle after drinking in few months, it is not good for health. You are not supposed to drink more water into that. 6 months, expiry date of these water bottles are 6 months. Do you know that? More or less 6 months. Should not use more than 6 months. These plastic water bottles, still you can use for a long time, but not for plastic. Plastics are maximum period is 6 months. After that is bad for health because continuously chemical leaching taking place. 6 মাসে পরে বোতল ইউজ করবে না, প্লাস্টিক বটল। And if you want to get long lasting one, use stainless steel bottle. Okay, so this plastic after disposal, you just instead of disposing here and there, if you cut the bottle into half, or the only the fine mouth portion if you cut out, and the rest portion you fill up with some soil and put some plant into that, it can be looking good. Okay, decoration, it can be used in decoration. That is reuse, application of reuse. And what else we can do? One is recycle, another is reuse. আর কি করা যায়? Refuse মানে don't produce pollution. So refuse to produce pollution. So minimize the pollution. Okay, we may take some preventive measures so that pollution will not happen. That is reuse, recycle, and reduce. As much as possible we can reduce the pollutants. pollution. Okay, these are called 4 R's. Very important terms. 4 R's into pollution prevention. 4 R's. 4 R's are very important. These 4 R's. Okay. So anyway, so polymers are very good, but it has got a very important problem also, very serious problem for us, and that is disposal. Ultimately, if you cannot do anything, what you do? Dispose, and that disposal creates a nuisance. That creates trouble. What type of trouble? Plastic bag will go into the soil. It will not mix up, but it will block the water passage, and afterwards the aquifer, the underground water reservoir, water level will go down. Environmental impact and innovation, non-biodegradability, that I was telling. It is non-biodegradable. But you may know or may not, I don't know, some bacteria is automatically generated from nature. They are eating the polymers. Okay, but that is still not very large quantity. It is stray away here and there, it is found. Okay, it is a research level. It is found that some bacteria generated by nature itself. That means nature taking care of its own protection to prevent pollution. Okay, so this bacteria is degrading the polymer also, but it's not enough yet. So biodegradable polymers we are supposed to use as much as possible, as much as practicable and possible, feasible. We should use biodegradable polymers. Like nowadays, if you give some online order, you get the package delivered into paper bags. Nowadays, people are supplying paper bags, jute bags, but not plastic bags. Plastic bag is slowly getting discarded, or people are refusing, okay, to use. Solutions are different type of innovations, daily uses. Have you heard about the plates that is edible? Edible plate. খাবারটা খেলে প্লেটটাও খেয়ে ফেলে। হ্যাঁ, শোনোনি? শুধু প্লেট না, প্লেট, কাঁটা, চামচ সব খেয়ে। হ্যাঁ, এই মানে টেস্টি। ওয়েফার তো খাও, ওয়েফার, ওটা ওয়েফারের মতো খেতে লাগে। তো কি খারাপ হবে? আসলে এটা এডিবল মেটেরিয়াল দিয়েই তৈরি। দিস থিংস আর মেড অফ এডিবল মেটেরিয়াল। Okay, that is nowadays disposable this plates and spoon and fork is bad. So instead of disposable one, if it is edible one, it's the best one. You are eating your own plate, so nothing is wasted. So that type of material should be used for daily use. Instead of disposal, take the whole thing. After eating the ice cream, you are eating the cone also, the same way. Okay, wound healing application. এটা কোথায় ইউজ হয় বলতে পারো? Suppose someone has got a very serious burn. So synthetic skin that is made of polymer. That is application. Synthetic skin can be made. That is polymer. So okay, what synthetic skin will do? It will protect and it will help to heal, because it will not be exposed anymore to the air. It will be sealed. So, and after that it will slowly dissolve. The skin will dissolve, and our own skin will develop. It will grow. It will give time to grow, and bacterial infection will not occur. Got the idea? Okay. Nanoparticles. That is one very important application of polymer. Nanoparticles, nanopolymer. Why you are using? Okay, suppose this is a polymeric small chain, very small polymer chain. One end you are attaching some fertilizer, and other end is already attached to the soil. So what will happen now? This chain is actually nano size particles. This chain is nano size particle polymeric chain. Now one end you have the fertilizer, other end is attached to the soil. Then what will happen? It will not be washed out. So that type of idea coming from nanotechnology. That's why nanotechnology is so important and useful nowadays. Okay, so that's all. Different type of this there. smart polymers, nanocomposites, sustainable polymer development. Some polymer which can be sustainable. Sustainable means it will be helpful for energy renewal. This polymer will not hamper the environment. So that is sustainable. What is the meaning of term sustainable? We have to sustain our future. That is the only thing. Sustainable means that will help to sustain our future. That is sustainable. Sustainable polymer, sustainable this, sustainable that. The meaning is so that we can protect our future. We don't ruin your future, not career. Future means our future life. Nanocomposite, different type of nanoparticles are utilized. We are making nanoparticles. Okay, this is the conclusion. Polymers shape our world. Understanding polymers unlocks profound innovation in material science. The probability is huge. Polymer probability is huge. You can make your own polymer. Every day some new polymer is getting discovered. Every day. Just imagine. Whatever polymer you know is fine. Apart from that, every day some new polymer is generated. How? Combine two polymers, you get another polymer. Have you heard about interpenetrating network? No, obviously no. You know crystal. Achha. Crystal polymer is amorphous, so it is not a crystal. So one polymer chain is twisted coil, like a twisted coil. Another polymer chain is also a twisted coil. If we allow two polymers to grow and together, and certain point of time, sometimes it may happen, one polymer frame, the whole framework is intertwined into another framework. Entangled. Could you understand or not? Entangle bojo? এইটাকে বলে entangle. Until unless break it, cannot separate out. That is called entangle. Now one polymeric framework entangled into another polymeric framework. That is called interpenetrating network. There is a new idea about polymer. Did you know this? তুমি জানতে তোমরা? Some new information. Polymers, you know, is like a coil. Okay, chain, thread, coil. One coil entangled into another coil. That is called interpenetrating. So that way, what is the benefit? We can get different properties. So many properties. That's all. Thank you.